We will learn about method 2 for factoring trinomials where a is greater than 1. This method is called factoring by grouping. So the steps here look like they are kind of long, but once you get the hang of it, hopefully you will be able to do it pretty quickly and easily without having to think about the steps over and over again. We always still want to look for that greatest common factor first. That makes our steps a little bit easier. And it also ensures that our final answer is in completely factored form. So here are the steps. I'll walk you through some examples as well. It takes a while to remember or memorize these steps, but once you do it several times, you should be able to do it pretty seamlessly. So the first thing you're going to do is you're going to take that trinomial ax squared plus bx plus c plus or minus, and you're going to multiply the a times the c terms together, the coefficient of a and then c. And then you need to figure out which factors of a times c will add up to the b term in the middle. Okay, now we need to then rewrite our trinomial and split the bx term into the sum or difference of those two factors. So it's not as easy as just saying, okay, what's a times c, and then what two numbers add up to give me b, and then that's my, those are my binomials, like when a is 1. So we have to then split that into the sum or the difference of those two terms. And then we're going to group the first two terms and the last two terms, factoring out a greatest common factor from each binomial, and then finally writing our answer as the product of binomials. This will make more sense with an actual example. So let's get started. So step 1 is to multiply 6 times 7, which is 42. Then we need to list, what are factors of 42 and which ones add up to 23? So 42, obviously we have 1 and 42. We have 2 and 21, which adds up to 23. So what I need to do now is I need to rewrite my trinomial, but I'm going to split the 23 into the sum of 2x and 21x. It doesn't matter what order they go in, but I need to split 23 into the sum of 2x plus 21x. The next thing we do is we group the first two, and then we group the second two terms together, leaving nothing in the middle, not even the plus sign. And you'll see why when we do an example with subtraction. After this, we look in each quantity, and we are going to factor out the greatest common factor for each one. So 6x squared and 2x, that is a greatest common factor of 2x. What's left is 3x plus 1. And then the greatest common factor of 21x and 7 is 7. And so we're going to put a plus sign in here because it is adding a 21x. For addition, it's not so big of a deal if you forget to group the plus sign, but with the subtraction sign we have to, because it will give a different answer, and I'll show you that when we get there. But plus the greatest common factor here is 7, and what's left is 3x plus 1. Now you might notice, and this has to be true in order to make sure you're doing this correct, but what has to be true is that this quantity and this quantity must be identical. Okay, and what that means is that if I am multiplying 2x times this quantity and 7 by that same quantity, that is the same thing as saying 2x plus 7, that quantity, times 3x plus 1. Because if I'm multiplying 2x by 3x plus 1 and 7 by 3x plus 1, essentially that's what we're doing when we are doing the FOIL method. If I were to start with this answer of 2x plus 7 and 3x plus 1, I would be multiplying 2x times 3x and 2x times 1, which is this right here. And then I would be doing 7 times 3x and 7 times 1, which is this quantity right here. So once I get to this step, first check to make sure that these quantities are identical. If they're not, you made a mistake somewhere up above and you need to make an adjustment. And then you're going to take the 2x and the plus 7 and you're going to group those into one quantity and multiply that times the shared quantity that they are both being multiplied by, which is 3x plus 1, and that is our answer. Now that's a lot of steps, so we need to do another one or two to make sure that we get those steps down. So here we go. These are the same examples that we did with the trial and error method. So starting by first multiplying a times c, 2 times 2 is 4. Now, we have a minus b term, so if we have a minus b term and a plus c term, that means that the two factors have to both be negative so that we have add together to get a negative but multiply together to get a positive. So factors of 4 are negative 4 and negative 1, negative 2 and negative 2. So which two of these multiply together to give us a positive 4 but add together to give us a negative 5? That's negative 4 and negative 1. So we're going to now take that minus 5a and we're going to split that into minus 4a and minus 1a. Again, it doesn't matter what order you put them in. And then bring down the 2a squared and the plus 2. We're going to group these together, and then we're going to put a plus sign in the middle. Okay, the reason that we don't want to keep that minus sign in between is because, and I'll erase this in a moment, so don't write this down, but if I did this, and I left that subtraction sign in there, you're telling me that I'm subtracting this entire quantity, the 1a and the plus 2. But I was not doing that. I was only subtracting the 1a, not the plus 2. So we want to group that minus sign with the 1a because that's the only thing that's being subtracted, and we want to make sure that the plus 2 stays a plus 2. So we do that by just keeping the minus sign with the 1a and then putting a plus sign in between. So what it looks like is plus a minus 1a and then plus a plus 2. So we don't want to make sure that we leave that subtraction sign in the middle there. Okay, so now that we have them grouped, now this is where we look for the greatest common factor of each. So the greatest common factor of 2a squared and 4a is 2a. And when I divide that out, I'm left with a minus 2 plus, so bring down that plus sign, the greatest common factor here between negative 1a and 2, you could say is just 1, but remember we need these quantities to match. So right now I have negative 1a plus 2. I need it to become a minus 2. So what I'm going to factor out here is a minus 1. And then if I divide negative 1 by negative 1, I get a positive a, and a positive 2 divided by a negative 1 gives me a minus 2. So those two now match, which is good. And then I'm going to say, since 2a times this quantity and then plus negative 1 times the same quantity, my answer is 2a. And I can just write this, instead of writing plus a negative 1, I can just write 2a minus 1 times a minus 2 is our final answer. Let's give another one a try here. Step 1, multiply a times c. 7 times 8 is 56. Now this is negative 56 because the 8 is negative. So we need to list all the factors of negative 56 and find which ones add up to negative 26. So obviously we have 7 and negative 8, or negative 7 and positive 8, but those do not add up to negative 26. So we're going to need to try some other factors. So we have, it's divisible by 2, so we've got positive 2 and negative 28, or negative 2 and positive 28. So we have our winner here. That's going to give us, when I add those together, a negative 26. And so now I can split up my negative 26 term into the plus 2x and the minus 28x. Bringing down the first and the last term, keeping them the same. Grouping the first two, grouping the last two, putting a plus sign in the middle. Looking for the greatest common factor of 7x squared and 2x. Here it's just x, leaving us with 7x plus 2. Plus, again, we need this negative 28x minus 8. We need that to equal a positive 7x plus 2. So we're going to go ahead and divide a negative 4 from that so that we can do negative 28 divided by negative 4 is a positive 7x, and a minus 8 divided by a minus 4 is a plus 2. We have the same quantities there, which is good. That's what we need. And then we're going to take our other 2 that we're multiplying by those quantities and group those. X minus 4 times the quantity of 7x plus 2 is our final answer. Now here's one that we did yesterday. This one has a greatest common factor. I can show you why you want to look for the greatest common factor first by doing this twice. So I will do it without the greatest common factor first, and then I will do it with factoring out the greatest common factor so you can see the difference. So starting without looking for a greatest common factor, 4 times negative 6 is negative 24. What numbers multiply together to give us negative 24, but add together to give us a plus 2? So obviously, it's not going to be 24 and 1. You could do, let's see, negative 12 and positive 2. That's not going to work. Negative 2 and positive 12 won't work. We have negative 6 and a positive 4 and a positive 6, or a negative 4. That's the one that will work. So we'll split that middle term, 4n cubed plus 6n squared. Now these are squared, so we have to be careful with that. And then minus 4n squared, and then minus 6n. We group the first 2, group the second 2, put a plus in the middle. Pulling out the greatest common factor here is 2n squared, leaving us with 2n plus 3 inside, and then factoring out a negative 2n here, giving us 2n plus 3. And then we've got 2n squared minus 2n, and then that quantity times 2n plus 3. Okay, now you might think you're done here because you did all the steps, it's done. And you might forget to do this at the end, which is why I always say do it at the beginning. But technically, you could do it at the end. Looking at those last binomial factors, seeing if any of them have any more factors in common that you can divide out. So this is actually not your final answer right here. If you notice that 2n squared and 2n still have a factor of 2n that can be divided out of it, then we need to divide that factor out. That divides out of just this one, not this one, so this one stays the same. A lot of times we forget to look for the greatest common factor and then we stop here, but that's not fully factored because there's still a common factor there. If I notice that factor of 2n at the beginning, and I do that at the beginning, then I have 2n times the quantity of 2n squared plus n minus 3. Okay, so the 2n in the front is going to stay there throughout, or you can just kind of set it aside and just bring it down to the end and remember that you need that. That way you don't have to keep carrying it through. But then now you're going to do 2 times negative 3 is negative 6. What 2 numbers multiply together to give you negative 6, but add together to give you a plus 1? So we've got a positive 3 and a negative 2 that will do that. So we break that up. We've got 2n squared plus 3n minus 2n minus 3. Grouping those together, putting a plus sign in the middle. Factoring out our greatest common factor, which is now just n. So that'll leave us with 2n plus 3. To make this positive 2n plus 3, we'll factor out a negative 1. And then that gives us 2n plus 3 as well. And then taking the 2n plus 3, sticking that down here, and then the n minus 1. Notice we got the same answer by factoring that greatest common factor out at the beginning instead of waiting until the end and missing it. Now what if we start with something that is already 4 terms and not a trinomial, but it's already split into 4 terms, a polynomial? Then we don't start with the step of grouping. We don't have to do any of that splitting because it's already 4 terms, so we can do the grouping. So once you do that, you can look for the greatest common factor, which is x squared, leaving you with x plus 3. And then here the greatest factor is 2, leaving again x plus 3, and then giving us x squared plus 2 times x plus 3 as our final answer.